Good evening, everyone, and welcome to Spindle TV. My name is Laney Shaughnessy, and I'm going to be your host this evening. How are y'all doing again? Now, we're going to do a mic check and things, and we're going to make sure that you all can hear me. The first thing I'm going to do is I'm going to switch cameras for a moment. Let's go in here and y'all still with me? We don't want to do that again. Hopefully, you can hear me now. Testing one, two, three. Hopefully, you can hear me. That was a disaster. All right. Testing one, two, three. Let's do a sound check before we get started here. All right, all right. Lord have mercy. All right. So I was trying something with a new camera setup and that didn't work. I wanted to was trying to be fancy. That didn't work out. All right. Well, listen, I want to thank you all for joining me again this week. And I want to thank you all for the nice comments and everything from our finished project from last week. And before we get into tonight's project, I want to give a couple of shout outs. Let's see if I can get my screen loaded up here. And the ooh, the first shout out here is to James. Let's see if I can get James's photo into full screen. Work with me, photo. James took his take on the courage sign, laid it out a little bit differently with a different tiger and everything. And great job on that, James. James Park, I appreciate you for that. Thanks for sharing it on Spindle Training Videos page. I appreciate you. And I also wanted to shout out, see if I can get this one to load up. Landis. Landis took the sign to heart now. Landis took 5 pages of notes, and this is his take on it. He got that looking pretty darn snazzy, if I do say so myself. So big shout out, Landis, on that one. And I want to back up a little bit. Let's see if we can get back to the Spindle training videos page for a moment because I also want to shout out one more person. I want to shout out everybody, but one more person here. Let's see here. Where is that's the group. Let's get back into dun, 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 dun. Is my internet this big old screen? I can't do anything in this big old screen. Let's see here. I want to shout out everybody that shoots me messages and everything. If I haven't gotten to your messages or anything, I will get back to them as soon as I can. Let's see if we can get back into the page here. Get out of these notifications and let's go over to post. And this particular post has some relevance to tonight's class. Let's see if I can get this screen to pop up here. It's running a little bit slow tonight, a little bit laggish. Everybody's on the internet. They're all watching Spindle TV right now. All right, let's see here. Where is James? Kevin Big Fish. Kevin Big Fish, big old shout out to you. Let me see if I can get Kevin's oops, shoot. Not there. Not that one. Stop. Stop. Stand by. Hit the wrong link. Come on, work for me. I had everything so planned out. It was gonna be so smooth and slick. All right, let's get back over here. Nothing works as I was hoping. Come on, internet. All right, let's pull up Kevin's post here. Is it gonna show me Kevin's post? Show me the post. Show me the post. Hide from embed. All right, now. Come on. Show me the post, dude. This is a good post too. It's actually relevant. Oh wait, I think I was clicking the wrong button. There we go. I was clicking the wrong button, ladies and gentlemen. Kevin shared his first attempt at dovetails. We're going to be talking about dovetails tonight. Now, Kevin's attempt, his dovetail box that he made, utilized the dovetail gadget built within Vectric, where you actually can carve dovetails on the CNC table. This can be identified if I go into full screen. It's going to let me go into full screen by the fillet, these little dog bone fillet marks right here on the dovetail. That is the place where the bit can escape so that we have three nice sides for those dovetails to touch up on. And so, great job on that, Kevin. I appreciate you. Way to go on giving it your first try and succeeding. Okay. All right. Let's get back to me here. So, big shout out to everybody. I want to say thank you. We're going to make dovetails tonight. I need to really stress this for you. Okay. There are there's a few methods of being able to make dovetails. One is on the table, sort of like Kevin's example, using the dovetail gadget within Vectric. And this uses an end mill instead of a dovetail bit. It allows you to cut those angles and ramps and everything for those dovetails and all on the table, on your CNC table. Now, the method that I'm going to be using and the method that I'm going to be instructing tonight is working on a vertical board as well as a horizontal. Um, the vertical board is going to be our tail board for our dovetails, and the horizontal board is, no, I'm sorry, they're actually both vertical. This one doesn't have any horizontal. If I was doing half blind dovetails, there'd be a vertical or a horizontal. Let me get my stuff straight here. We're going to be working on the vertical for both the pin board and the tail board. If I was doing half blind dovetails, then we'd be working on the horizontal and the vertical at the same time, almost like if you were using a dovetail jig. Now, Device that I'm going to be using is the joint making jig. It mounts on the end of our unit, our CNC machine, and it allows our CNC to carve over the front of the table for the um, being able to cut on those verticals for cutting things like dovetail joints, finger joints, tenons for mortise and tenons, and different things. So I know that this may not apply because your machine might not have the capability of carving off the front edge. But definitely, consider it, take a look at it, and let me see if I can zoom in to this photo here. So this is the joint maker jig mounted on the end of the digital wood carver. It has hold down fences for your horizontal boards as well as vertical boards, allowing the unit to carve off the front. And that's what I'm going to be using to carve with and all. And I know it might not apply, in your case and stuff, but stick around with it because it's an interesting topic to learn how to design and lay out dovetails in Vectric when you're not using the dovetail gadget that's built within Vectric, that was created by Vectric or one of their users and stuff. Um, for those of you that are Digital Woodcarver customers, even Digital Woodcarver non-customers, be sure to check out Digital Woodcarver on YouTube tomorrow night at 7 o'clock. We're going to be live, myself and the owner of Digital Woodcarver Burl, and we're going to be demonstrating and talking about the joint making jig. This is called the DWC joint making jig, and we're going to be demonstrating it, and we're going to have a couple of special announcements about it and stuff. So if you happen to be around tomorrow night, check out Digital Woodcarver's channel on YouTube at 7 o'clock. We're going to be live. You can also watch live from the Digital Woodcarver Facebook page as well if you're on Facebook and stuff. Um, so tonight I'm going to be doing dovetails. Now, my two bits, the dovetail bits, the dovetail bit that I'm going to be working with, and the end mill I'm going to be working with. My dovetail bit is going to be the Fruid 2211.5 dovetail bit. Now, this dovetail bit has a 17/30 wide cutting head, 17/30, and the carbide is 25/30. So at the width, 17/30 by a cutting height of roughly a cutting height of 3/4 of an inch, but the carbide length is actually 25/30 if you want to be precise. Now, to clear out the waste areas before that dovetail bit comes and cuts, I'm just going to be using a very simple end mill. I usually use a 1/4 inch end mill for that, but tonight I'm going to be using a 3/8 inch end mill. And it's just a very simple 3/8 inch straight cutting bit that I'm going to be using. This is a very inexpensive bit. It's of the Bosch brand series. I don't discriminate against bits. If it works for me, it works for me. But it's 3/8 inches in diameter. Now, if my dovetail been smaller than what it is, my dovetail bit, then I would have went and stuck with my 1/4 inch end mill for clearing out all the waste area because the 3/8 inch wouldn't fit. And you'll see that as we demonstrate that in the training. So those are the two bits that I'm going to be using for my dovetails. And let's see if I can pull up my file for a little 3D rendering file here. See if we can get that popped up on the screen. And while that's popping up, we'll come back to that. And let's close this window that's finally popped up here. All right, let's go into big screen here. So this is the 3D rendering that I just drew up, kind of a rough, 3D rendering of the box that I'm going to be making. And the you can see the pin boards. I'm going to have the pin boards on the side with the tail boards on the front and the back. So um, the box itself is going to be 8 inches in width by 10 inches overall length. Now, I didn't go into great detail on the lid I'm gonna actually be doing a 3D carving on the lid and all, but I did not draw that up in a 3D rendering. I wasn't, I just wanted to get the box drawn up and everything. Let's see if I can kind of spread some things out here for a moment. You will notice, and we're going to be bringing this file into Vectric because in Vectric you can import SketchUp files, and then many of you may recognize this software that I'm here, this 3D software, as Google SketchUp. Google SketchUp I use quite a bit when I'm trying to visualize something three-dimensionally. I will, um, utilize it to draw with and all. And let me see if I can get these last two things moved out of the way here. Now, in the box itself, on the sides of the two parts, my or all four parts, there is going to be a 3/16 inch wide by 3/16 inch deep groove across the bottom on all four pieces for the bottom piece of material for the bottom of the box, and the little dividers. I think I'm just going to go with a simple break it up into four pieces. I don't think I'm going to go too extravagant on this for time's sake and stuff. But let me lift this up here and let's zoom in here. You will see that there are two dividers here. They are 3/16 inches wide by how tall are they? Let's by 1 7/8 inches tall, and they have little um, grooves cut into them in the center so that they can slide over one another into the part. Now, the bottom of the part, if we come in here and hide these two pieces for a moment, the bottom of the part is also grooved. It's grooved about a 16th of an inch deep for those to lay on. And you'll see that I have the uprights too that'll be fitting into this part here. So that when this box goes together, everything will kind of lock in. And then I think I'm going to be making it out of cherry. I pulled out some cherry boards. I usually I like to do contrasting colors where I have a darker color on the front and the side, but I couldn't find any walnut and I didn't mill up any maple over the weekend. So I just have some cherry that we're going to work with. And, that's what I'm going to work with for the project. And but Google SketchUp is a great little program, very fun to learn and 3D render with. And the files can be brought in uh, to Vectric. You can actually draw and then bring the files into Vectric, which you're going to see in about just a few minutes here. Now, let's talk about this. We've got one part here for the lid. We've got two sides, a front and back, so that is five pieces. 6, 7 for the two dividers, and then 8 for the bottom piece. So you'll see when I go into the VCarve software and I import it, it's going to tell me that I have 8 parts to import, and that's what we're going to do. We're going to import them on the flat, and I'm only importing them just for the sole purpose of cutting the little grooves and stuff for the and cutting the dividers and all out of the parts and everything. My dovetails, we're going to be designing them separately. Now, the link for SketchUp, SketchUp version 8. Now, I'm going to recommend. Now, one of my favorite woodworkers on YouTube is Jay Bates, Jay's Custom Creations. And I'm actually going to link you or recommend that you visit jayscustomcreations.com and go to his SketchUp section and download the version 8 SketchUp link that he has there. And also check out his how-to videos. Jay Bates is how I learned SketchUp. He's got, I don't know, 50 or 60 how-to tutorials. And I had a marathon and I watched those videos back to back playing around with it, and that's how I learned SketchUp. So I'm gonna recommend that you check out Jay's Custom Creations, and I'll get the link here for you and throw it in the chat. Let me get it pulled up, and I'll put the link in to the actual SketchUp page. But check out his whole website. Jay is a phenomenal woodworker, great guy. I haven't talked to him in years, but someone I consider a dear friend. And so here's the link in the chat. I'm about to post it right now. And that's going to take you to the page. Now, on that page, there's a link that says click here for a direct download of the US version. Then they have one for Mac version and English London version. I work with the US version, version 8. But he's got some SketchUp videos on that page and shortcuts and stuff. And absolutely watch those videos. They're great. Now, he's a little fast talker sometimes, but I was able to follow along very easily, not knowing a single thing about SketchUp. And now I consider myself to be pretty proficient in SketchUp, and it's all due to his training videos. So definitely check him out. Jay is awesome, and if he happens to ever see this video, hey Jay, what's up? Long time no talk. All right, so that is what we're going to be doing. Now you're going to see me working in VCarve Pro tonight, but I'm also going to be working in Aspire. And the reason why I'm working in Aspire now, everything that I do here can be done inside of VCarve Pro, but I had my file in Aspire when I was drawing it, and I'd like to be able to just kind of keep it there and not have to recreate everything because I want to be able to talk to you this for time's sake and stuff. But we're going to first start off in VCarve Pro, and we're going to import that SketchUp file so you can see what that looks like. All right, let's go ahead. Enough of looking at my face, even though I know y'all like looking at my face. All right, let's go ahead and get over to our software here. So I'm in VCarve Pro tonight, and we're going to go ahead and create a new file. And for this file, I'm going to just grab a 24-inch by 24-inch board just for the sole purposes of importing the parts. Once I get them imported, I'll come back and adjust my job set up based on the actual board that I'm going to be cutting them out of. But I want to bring all the parts in just to show you. So 24 by 24 inches is what I've got it set up to. And 3/4 inches the thickness of the material that I'm working with in this setup. But again, I will be uh, creating different setups and all. So the cool thing about importing, we're going to come over here under file operations and we're going to import a vector. And that vector file, with when we import, we can import drawing files, all the file formats of DXF, DWG, EPS, Adobe Illustrator, PDF, and then hiding back here in the corner, we have our SketchUp and SVG files, and then of course any of the Vectric formats like Photo VCarve, V3D files, V3M, those are 3D model files, and then CRV, that's our VCarve, standard model or standard project files and all. So we are going to be importing a vector, and we're going to be importing the Dovetail box here. Now I'm going to go ahead and close out of the SketchUp program. Not necessarily required, but I'm going to close that because I want to get rid of that auto save. While I was working there, it automatically saves those changes in case the computer crashes or anything like that. So I'm going to open up that Dovetail box SketchUp project here. And when it opens up, we're going to get a prompt. Now, I'm going to be doing an exploded flat view. I want all the parts broken apart. You saw my box was all together in its 3D assembly in SketchUp. Well, this is going to explode those parts and separate them. You can see here that we have 8 parts to import. I'm just going to let the software auto-orientate, and large face is the top face. Now, if I wanted to, in my SketchUp, I could have painted the face that I want to be brought, facing up in the Vectric software, I could have painted them with a certain color, and I could have said orientate by material face color, and I could have came in here and chosen one of those colors, and it would bring all those faces upward. You know, I'm not going to do that. I'm just going to auto orientate. Now, where the software has polygons and stuff in SketchUp, I want the software to create, circles, for those polygons. And I want it to fit arcs to boundaries. Basically, it tries to fit arcs to the appropriate SketchUp fillets, those fillets and stuff. I want it to group the imported parts, together. And I want it to keep my components together as well. My components, again, it's a SketchUp thing, but when you can take a project and when you extrude it into that 3D piece, you can take all of the faces and group them together into a single component. And I want it to keep those components. Okay. So if I wanted to, if this was a three-dimensional type design, where I needed to be able to view the front, top, and side of a part, then I could bring in the 3 view and it would bring in the 3 views of each individual part, front, top, and side. And I don't want that. I don't need all those parts laying around. I just want it to bring in 8 parts here. So extruded flat layout, auto orientate, create those circles and arcs. I'm going to group those two. I'm not replacing the outer boundary. We're going to click OK, and it's going to bring those 8 parts into the screen. So this is my front piece and my back piece here, one side and the other. This is my lid, my bottom, and then my 2 dividers here. Okay. And so if we look at this, we're looking kind of at a side view of what a dovetail pin board looks like, because it has that angled cut on it and everything. So these lines, and you're going to see how those when we actually draw the how we create that, because we're going to manually create these. Now I could have cheated. I could have used the SketchUp file here. I could have imported that in and created my dovetails right off of this rather than drawing it, freehand. But I want to draw it freehand to show you guys how to set up your parts. Okay, but that's how easy it is to import a SketchUp file. And one day we will have a class on working with a SketchUp file from start to finish. This will not be that class, because we do have a lot to go over tonight, and I want to try to get it done in a timely manner. So, with that being said, we're going to jump into it right now because some of this for you guys and girls that are new, I don't want to lose you on it. It might be a little bit like, what's he doing? I'm going to try my best to explain every step, and I am going to use a method that I learned from, and believe it or not, I learned from another competitor of Digital Wood Carver. Uh, they are, hold on a second, Legacy CNC Woodworking. I don't know anybody at Legacy. I just used to take their classes and stuff. I liked their projects and things. And they did a dovetail class when I was learning dovetails. And that method stuck with me. I thought it was a good method for creating dovetails for cutting on a vertical and everything. And so I am going to teach you that version, but in my own interpretation, how I took it and everything. So, Legacy, I don't know anything about their machines, the quality of them, any of that stuff. I don't know anything about their company at all. I know that they used to teach prep classes at the woodworking show, and then I took over teaching those classes at the woodworking shows. That's about all I know of them. But hey, good on them. They're great people, good classes. You know, I'm not going to speak on behalf of their products or anything because I don't know anything about them. All right. That being said, let's get on into it. Now, we're going to jump into the Aspire project here, and again, we'll get back to this and talk about creating our pockets, but we got a lot to do with the dovetail side of things. So we'll get back to cutting these parts out and creating the toolpath form in just a minute. And then one day I will teach a class on importing, creating a project in SketchUp, and then importing it in and taking it all the way to toolpath, in the software and stuff, and then possibly even creating that project, whatever it may be. And we'll do that in the. All right, let's minimize this and let's get into our Vectric. Now you're going to see a lot of stuff on the board here, but we're going to kind of start over here to begin with. You're going to see a lot of numbers and you're thinking, "Oh, Jesus, Laney, we got math to do." No, we don't have a whole lot of math. Um, the one thing that I've got drawn here is my clearance bit diameter, right, is going to be a 3/8 inch diameter bit. And like I said, on my smaller dovetail bits, I use a 1/4 inch, but this is a little bit of a larger dovetail bit, and my 3/8 inch bit will work for what I want. And I, it's new, it's nice and sharp, so I'm going to use it on this project. Um, The dovetail bit itself, like I said, I showed you to you live. It's the Fruit 22115 dovetail bit, and it has a cutting diameter of 17/32, and it has a carbide length of 25/32. It does have a 1/2 inch shank in it, and it has a 7-degree angle on that dovetail. So simply what I've done in the Vectric software is I came in and drew that tool. Now let's go ahead and redraw it again, just so you can see how to draw the bit out. I'm going to use the line tool here. And actually, let's use the rectangle tool. So on the rectangle tool, I'm going to, my width of my bit, the widest diameter is that 17/32. And notice I typed in the fraction here. I'm going to hit the equal key on the keyboard. It'll do the fraction to decimal conversion for me. And the overall carbide height is a 25/32. And I'll hit the equal key again to get that in there. And I'm just going to bring my mouse over on the screen and click here to create that. Now, I'm going to use the line tool, the polyline, draw polyline tool here. And I'm going to draw a polyline here. And I need to um, kind of, find my angle and everything. And I could freehand it. It's 83 degrees. I could sneak up on 83, and try to get, I could zoom in and get on 83, right? It's going to jump. I'm going to zoom in any further, and I could get there and click there and I'd be done. But I want to show you how to use the polyline tool appropriately. So I've created my start point here by clicking down in this bottom left corner. You can see I've got my line is still stuck to my mouse. It's waiting for some direction. Well, I'm going to come over here to my angle, and you have to remember now the software works from 90 degrees, 0, 90, uh, 180, or 135, 180, 270, so on and so forth, all the way around to 360. So 90 degrees minus my 7-degree angle is 83 degrees, because 0 is straight across to the right. I want to go 83 degrees, which will give me my 7-degree angle from vertical. Okay. So 83 degrees on the angle, and the length is going to be 25/32. I'm going to hit equals to get that in there. And I'm simply going to click add. That's going to create that line. Now I'm going to come in here and I could either click the finish button or I could click on my space bar to finish that button. I'm going to just click the finish button to create um, that angle, that length. Okay. Now over here, I'm going to do the same thing. And this time I've clicked to start the line, but this time now I'm going past 90 in a positive direction. So it's going to be 90 plus 7. So 97 degrees and same length. And I'm going to click add to create that line. Okay. Now notice my other line over here, shot over here. I'm going to hit finish to finish this line and it'll go away. That line was just there because I drug my mouse over to click the ad over here on the ad, but as soon as I clicked finished, it got rid of it. Now that I the lines drawn out, I'm going to basically take my box here and I'm going to grab it on the top here and just snap it down to the top of those lines so that I can use my scissor tool. And I'm just going to click here. And I don't want this line at the top. So that is a span. So I'm going to go into node editing and I'm going to right click on that line and delete that span. Okay. A span is a line, arc, or curve that is between two nodes. All right. So how many of you did I lose just on drawing the bit? All right. Hopefully none. Hopefully I didn't lose any of you. Now let's get out of node editing on that bit and let's look over here at what I've got. Basically, I've kind of drawn out the diagram. I've kind of given myself some information, what my clearance bit diameter is and what my dovetail bit angle is. And that bit that I drew, which is the same as this one, the reason why I draw that is because I'm actually going to use it in the setup over here. I'm going to use it in the setup and everything. And we're going to talk about the setup in just a second. But if I were to measure this angle and everything, the software is going to read it as 83 degrees, that inside angle. But it's also 7 degrees, from 90, 7 degrees. Okay. So that's my dovetail bit. All right. Now you can see that dovetail bit. I have drawn it up here at the top. And I would like 5 dovetails to go across my piece. And I would like them spaced accordingly. Now, my part is only 4 inches wide. Let me put that 4 inches in there. Okay. And let me get it snapped to the center there. Snap. There we go. And what I would like is on my dovetails is I would like half a pin on each end and then 3 pins spaced out evenly. Now, these dovetail angles here are not my actual dovetails. It's up here across the top that are when I put the lines in. You'll see that in a minute. But I want to evenly space them. And for me, with the size of my bit and everything, it came to an equal spacing of 0.04688. Now, how did I lay that out, or what was the easiest way to lay out how many pins I want? Because I could, get rid of pins and I could have it as a 3-pin thing where I just have one big dovetail in the middle. It doesn't have to be the size of your bit. You can lay out your dovetails as long as your bit can cut the part, your dovetail bit can cut it, then, that's fine. I could have one big dovetail in the middle and 2 half pins on each end. I could do all kinds of things. But I want equal distant dovetails on this board. Now, what was the easiest way for me to lay this out? Well, let's come over here into a blank spot and I'm going to draw my piece. My front piece, my pin board or tailboard, sorry, tailboard. It is 4 inches wide by 10 inches in length. Okay. So let's click over here and create that. Let's get rid of this one where I accidentally double clicked. Okay. Now, if I take that dovetail that I drew out for you guys just a second ago, I'm basically going to come over here and snap. I've got smart snapping and geometry snapping on, but I've grabbed that dovetail right in the center, and you can identify the center by that little diagonal mark on your cursor when you hit that center line. When I'm in the center, it'll snap right to it. And so I'm snapping that right to the corner here. Now, I will hold down my control key while I'm in transform mode. Transform mode is when you double click on the object and put it in transform mode. Or if I went over here, I could use this tool, which is called transform mode, which will do the same thing when I select an object. And in transform mode, my control key allows me to make copies when I drag my part around. So if I hold my control key down and I grab that part in the middle there, I am dragging a copy and I'm going to snap it to this end. And this is going to represent my 2 half pins on each end. Okay. You guys with me there so far? All right. Now I'm going to grab my control key again, and I'm just going to grab this part up here. And I'm actually I want 3 more pins in between here. I want a total of 3 and 2 half pins on the end. So I'm going to hold my control key down and drag 3 more out here. Okay. Just holding the control key down. I got those down. Now I'm going to utilize my alignment tool and my rectangle tools to help me lay out my pins. So first thing I'm going to do is I'm going to draw a rectangle that basically is the width of my 2 bits here. All right. And I'm also going to draw a rectangle on the inside right here on that inside of that right side of that bit. I'm also going to draw a rectangle and I'm going to snap to the inside left of this one. And with that, I really don't need this outside rectangle. We can get rid of that. We just have this in here. I just wanted to show you my overall length. All right. Now, this is the space to which I want to space each of these 3 pins equal distance. Okay. Between my 2 half pins, I want these spaced equal distance between the 3. From this point to this point. Y'all still with me? All right. So here we go. I'm going to select my 3 parts first. Hold down my shift key and select my inner rectangle here. Or not my inner rectangle. Well, inner rectangle. Yeah, technically it is. And I'm going to open up my alignment tool. And I'm going to be aligning to selection. I'm aligning the selected objects to the last item in the selection. Last item I selected. So I'm going to center them right now in there. And they're all stacked on top of each other right now. And now I'm going to come down to space inside the last vector. I'm going to space them equal distance horizontally or vertically. In this case, horizontally would apply and space them out. Now I can come in here and I can delete that rectangle, and that's going to give me my dovetail spacing. Okay. Y'all with me? Cool. All right. Now, just for kicks and giggles, if I were to measure horizontally between each of these parts, okay, I would be equal distance. All right. And that's the setup that I want. That's what I want, you know? So let's go ahead and close that. All right. Let's get rid of these dimensions. All right. Now we're going to start the layout. What our goal is to end up with a part that looks like this. Okay. And I'm going to go ahead and delete these numbers. They don't apply right now. So what my goal is to end up with that part. Now, key thing is, how thick is my material going to be? My material is going to be 5/8 of an inch thick. The walls of my box are going to be 5/8. And, you know, it's a heavy box. It's, you know, that's not a thin box. Typically walls, you know, for jewelry boxes, they're going to be 3/8 or something like that, you know, half inch and everything. Um, uh, but I want to, my box is going to be, the walls are going to be 5/8 of an inch thick. So imagine that if we go from a side view here, imagine if I have my, let's go 0.625. Oops, not 625. Let's try 0.625. And let's draw another rectangle here and make that 0.625. Okay. When my front pieces fit in to my side piece, that dovetail cutter has to cut that 5/8 of an inch thick, you know, or 5/8 of an inch deep, if you will, to create so those two parts can fit together. Now I'm actually going to overcut by 1/8 of an inch. I like to have my parts slightly proud when I assemble them together, and then I will sand them flush. We'll overcut it by a 16th of an inch, not an eighth. So I'll have them slightly proud by 16th of an inch, and then when it's all glued up and everything, then I will sand everything flush and make it nice and tight and right. Okay. So that being said, that being said, I need to move these parts down my 5/8 of an inch plus that extra 16th, right? So I'm going to come over here to my move tool and I'm going to move relative to its current position on the y axis. Y is up and down on your screen. And I'm going to move down. So that's a negative number. And I'm moving 0.625 plus that 16th of an inch, right? A total of 0.6875. I'm going to put my negative sign in the front and I'm going to click apply. Okay. All right. Now here's where the magic happens. We're going to take our scissor tool here, our interactive trim tool, and I'm going to go ahead and cut away this end, that piece, that little overhang. I'm going to cut away that little overhang, that piece, and that overhang. That one, and that one. Same thing there. And over here, that, and that. And what do I have? I have my L board, right? One half of it anyway. There's another half down here. But I only need to create one side. I'm going to be flipping the board over to do the other side. So I only need to create one side because of the way that the tool paths are going to be done, which we'll get into in just a moment. All right. So that's how I create the tail board. Simple enough, right? So pretty good there. All right, let's stop for a minute. Let's see if you guys are freaking out in the chat room or asking questions that I haven't seen. Let's see what we got here. Welcome, Peter Renner from New Zealand. Thanks for catching in and watching us. Let's see here. Dean, you keeping them all straight out there, buddy, with those likes? All right, very cool. So let's get back to it. Like I said, we've got a lot to go over. So, hello, Crystal. Good to see you again. I know things are crazy, but Laney and his trainer best. Thank you very much, Crystal. I appreciate that. All right, so we've got our tailboard created. Now, phase 2 of this project, right? Phase 2 of the creation. You see these boards down here? All right, so phase 1 is creating the layout, right? The layout. And that's what I did. I created the layout. So if I were to delete this and delete this box right here and drag this over, which you don't have to, but let's drag it over. All right, that's my layout, okay? And we don't need this over here anymore. So I've created the layout for the dovetails that I want. All right, now I've got to create the pin board. And how am I going to do that? Well, this little graphic down here should give you a slight little indication. It's not quite a mirror of it because these are positive, these are negative, but that's how we're going to generate that. So let's go ahead and delete these out of here. Okay. And I'm going to take a copy of my layout board and hold down that control key and drag a copy down. And I'm going to hit the number 0 on my keyboard to turn it 90 degrees. Hit it twice so it rotates because it rotates in 45-degree increments. I've got it laid out here. All right. Now, my tail board or pin board, sorry, my pin board, pins and tails, my pin board. My pin board is also 4 inches in width, and it is a overall length of 8 inches. Now, these overall lengths and everything are not important. You're going to cut your pieces down to size. What's important is how those pins and tails are laid out because we're actually going to be cutting on the end, like we're looking at an end view of the board. You know, that would be an end view. So the end view of the board, that's why it looks like, or the top view, if you will, like looking at a board from the top down when it's in the vertical position. All right. Now, if I came over here and took this piece and snapped it right to here, you would think that I'd be able to just cut the vector here, and copy and paste it, you know, and then trim everything together and blah, blah, blah. And it doesn't quite work that way. What we want to do is we're actually going to use our tails so that we can draw our pin layout. We're going to actually use the Polyline tool for this. Okay. And the Polyline tool is just going to be a series of click, 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 right? We're going to click at the edge of our board here, right? And we're going to come and click on this inside corner, click on this end over here, inside, this one at the end, over here on the inside, and I'm just clicking, right? When I get to that point, I'm clicking. Now, this is much easier in the 9.5 and 10 with the smart snapping and stuff and the geometry snapping, but I used to do this in version 8, 8.5, 9, 9.5, and space bar to finish the line. So it can be done on all of them. Now, notice right there, I'm going to kick myself in the butt if I wasn't snapped. I wasn't quite snapped to the corner, so everything I just drew is off by that much because I'm a goofball. So we're going to undo that, and we're going to get our boards lined up. Lord have mercy. One more time. Y'all needed to see it again anyway, right? All right, one more time. So here we go. We're going to start at the edge. I should have checked that before I started talking smack. All right, let's go over here. And we're redrawing. All right, space bar to finish off the line. Okay, now I have this polyline, and I'm going to hold down my shift key and select this, my pin board piece, and we're going to slide it back. And there's our layout here. Okay. And so now that I have that drawn, I'm going to come in with my trim tool, and I'm going to trim away in between these lines to create that negative layout. Okay. All right. Now I've got these two lines right here overlapping. Don't want that. So I'm just going to take my trim tool and click it once. And that should have joined that one. You can see my other individual lines right there now. I can select them and hit delete on the keyboard to get rid of those. And I've got one more overlap down here. Do I have an overlap down there? Is he hiding or is he gone? Did I get him? No, he's still overlapped. He's just hiding. I'm going to trim that away, just a single click. And there we go. All right. All right. So now I have my layout. And if I could turn this thing 90 degrees, you would see kind of a three-dimensional view of how it fits. Um, you know, okay. Now, phase one was layout, getting the pins laid out. Phase two was creating the tailboard. Now we're into the final phase, setting both of our pin board and tailboard upright and creating the vectors for the tool paths. Okay. All right. So we're going to take and I'm going to hit the number 9 on my keyboard this time and turn that vertically counterclockwise. I'm going to hit the number 0 on my keyboard and turn this vertically clockwise. And this is going to replace, let's get rid of this and this. Hit delete. And we're going to bring these guys up into place. Tried to lay this out the same way I learned, but also for you guys. Now notice I didn't make copies. I just brought them up here. I don't really need that layout down there, but layout too, you know. All right. When I save these files for you guys, now these files really won't be any good to you unless you had this cutter. But I will still provide the file to you so you can kind of examine the layout thing. So hopefully y'all are with me and this is not boring to death, but we are reaching the final round here. Now, what I'm going to do is at this point in time, you can see I have all these layers from past projects and everything. And what I want to do is I want to start fresh with you guys and girls. So I'm going to come in here and I'm going to turn off the vectors over here, which is going to be my board in a moment. You'll see that job setup in a second when we get into the job setup. And I want to, I'm going to add a new layer and I'm going to call this, evidently it's going to yell at me for, there we go. I'm going to call this our class tailboard. And class and board. I'm going to take these two vectors here and here, and I'm going to move them, well, one at a time, Lainey. Tailboard, I'm going to go ahead and move it to the tailboard layer. And pinboard, I'm going to move that to the pinboard layer. So now I have them on separate layers. I can turn those vectors on and off if I need for whatever reason. The reason why I want to do that is because I want to focus in here and I want to be able to kind of clear all this stuff out here in a second. But I'm going to, instead of clear this out, I'm going to select all of this and all of this. And I'm just going to move it up out of the way. It's going to be in your eyesight. You're going to be wanting to stare up at it and all, but we're going to draw two new boxes. Same thing with this and this. We're going to move that up here because we're going to draw two new boxes. So our boxes are going to, you guessed it, they're going to be the size of our part. So 4 inches wide by the thickness of our piece because we're looking at a top view, 0.625. Okay. And I'll have to move this all over. Let's do this one. 4 inches wide. 5.625. All right, let's get some things lined up and cleaned up and everything here. Move that to the side. And for those of you with OCD, let's get that somewhat centered here. I'm gonna drive y'all nuts. You'll be like, I can't pay attention, Laney, man. Get that shit fixed. All right, let's go over here and let's slide this over a little bit. And let's take this and slide it over a little. All right, now what the key to all this is we absolutely have to have things in alignment for these two boxes for this next layout procedure. So I'm going to snap to this edge here and then just bring it straight up so that I'm in alignment. Same thing here. I'm going to grab this one. I'm going to grab it right on the corner, snap down here, and then just raise right up along that dotted line. Okie dokie. Okie dokie. All right. Now, this right now does not look like a pin board. This looks like a reverse dovetail. Doesn't look like a pin board at all. How we get it to look like a pin board is we're going to draw some vertical lines from all of our points, our inside and outside points. What I mean by that is from this outside point here, straight up, 90 degrees, space bar to finish. And this inside point right here, straight down, 90 degrees, space bar to finish. Here, straight down, 90 degrees, space bar. And on this corner, straight up, 90 degrees, space bar. Now, if I came in here with my scissors and trimmed away that, not that line, trimmed away those two middle lines, what we're getting is a representation of that angle, that offset angle. You know, you got to use your imagination on that. And so we're going to repeat that for all of these. It's important that we do because we got to extend these lines up into our part up here. So we're going to straight up. That was not straight up. I'm going to undo that and undo that. There we go. I accidentally clicked when I shouldn't have. Space bar to finish. Over here, straight down. Space bar to finish. Here, straight down. And here, straight up. All right, I'll come back and trim those lines. Let's just keep going with the Polyline tool while we're at it. And inside and outside corners. So the outside corner here and the inside corner here, we're just snapping and drawing a 90-degree line up and down. One more. All right, now I can come in with my scissor tool and trim away those diagonals. And now we have an official looking tailboard and pin board. Okay. All right. Now, for those of you that may be just slightly lost on that pinboard tailboard, let's open up our 3D view and take a look at them in a 3D rendering real quick. All right, let's go in here and let's take this piece, this piece, this, and this, and let's hide those. And let's look at, let's move this one out. And let's take a look at this one here. Now I'm going to rotate, I'm going to orbit around this one here. And on this side here, let's go with a straight camera view, camera, standard view, front. How about back? Camera, standard view, back. There we go. All right, so this is my tailboard or pin board. Yeah, tailboard, sorry. This is my tailboard. Let me get the blue off there. And let's spin it around here. So very straightforward as far as that tailboard goes. Same thing as what we're looking at here. Okay. Now on the pin board, we're going to rotate this around 90 degrees, and I'm going to rotate this 90 degrees. 90, enter. Hard to get out of that. Let's look at it from the end. And I'm going to tilt this ever so slightly. Okay. That angle here that we're seeing, those lines that we drew, if we put this in a vertical, those straight lines that we just drew, that inside line represented, the outer part of that angle. And that inside line here represents the narrow part of the angle. So when we're looking at this, the outer part of the angle, the inner part of the angle. Okay. So that's what we're looking at when we're looking at it straight on. Now, the boxes, the individual boxes that I drew up here where we're going to be extending our lines, that's going to be basically a representation of a top view. If we were looking at this board in a top view, from the top down, at that end, that's what we're going to be kind of creating next. All right. So that when you were looking at that vertical piece and wondering how if you couldn't visualize what those lines were doing, it's basically kind of in your imagination, it's kind of emulating that offset of that angle cut right. All right, cool. All right, let's get back to it. All right, now you can see it, right? Your eyes are like, oh, I see it now. I see it. I see it. Okay, now what we have to do is we have to extend these lines up to create our top views. Okay. And so on our top views and everything, we have to extend the lines up. And, basically, we're kind of looking at, the top view of the tailboard here. It's just a box with lines in it. But the pen board is going to have kind of those angles that you see there and stuff. Right. I'm like, how did you get that? All right. Let's figure that one out. All right. So on our just coming back up here, we have our this is the pin, this is the gap between or I'm sorry. The wide ones are the gap between the pin, then the pin, the gap, the pin, right? So what we're going to do here is we're going to create with our polyline tool, basically from down here, we're just going to extend a line straight up. Okay. A line straight up. And what we can do, and I actually clicked on the wrong place in there. Actually, it needs to be on the top of the pin. Sorry. Straight up, space bar to finish. 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 Straight up. And I'll shut up for a minute. Quit saying straight up, straight up, straight up. That's irritating. All right. All right. Now we're going to take our scissor tool and we're going to trim some things up. Get rid of our little overlap here. Okay. So this negative space right here represents our half pin. This is, the void right here. That's the top of the pin. Down here is this opening here. This is the top of the pin. This is this over here. We don't need, draw in the bottom. So you can see the negative space and all. All right. All right. Because our router bit, our tool paths are going to be cutting, you know, here in these areas. That's where our router bit's going to be cutting those areas. Not at an angle like that, or it'd be a bad day for it. All right. So we've got that one drawn out. Now, this one, this one, we've got to be able to pocket out these areas. And uh, for this, we have basically, we have kind of a line where our angle is going to start and where it's going to end to create that offset, that angle here, that angle cut. So let's get that one drawn and see. We'll do one and you can see where I'm going at here. So now on this one, basically I'm just connecting that to here. And this one I'm going to connect here. And if I were to connect a line from here, I could come in with my scissor tool. Oh, don't turn away that one. That would create that first angle that have in it. Okay. So we're going to do that all the way down and then we'll come back and clean up our lines. All right. So this is the inside of the angle. Inside line is short, outside line is long. And I'm hitting the space bar after I click to lock in that line. I'm hitting the space bar uh, to finish the line. Okay. Outside line is long. Inside line is short. Inside line is short. Outside line is long. We're getting there. We're almost to the fun part of creating the toolpath layout. Like, hopefully y'all are finding this somewhat, finding something in this, some kind of helpful stuff or information. Um, outside line is long, inside line is short. All right, with my line tool, I'm now going to connect these 2 points. Just connecting these 2 points, the short line to the end of the long line. Okay. And then I'm going to take my scissor tool and I can go ahead and get rid of all of these cross lines here. And then my straight lines here. All right. And that is an end view of my pin board. Okay. All right. Awesome. All right. Now the fun part. Now comes the layout for the toolpath. Now this is going to involve our diameter of our bit. This is our end mill. So all the circles here are representing a drilling toolpath that our bit is going to come down and drill to hog away the waste material. The lines here are going to represent an end mill cut. on these short lines here, not this long one. The short lines are going to represent where the end mill is, cutting to hoggle out extra waste material here and here. And then the long lines represent where the dovetail bit are going to be cutting. And the rectangles kind of represent a pocket cut. Okay. Over here, we have drilling tool pass where these circles are, and a pocket cut where this kind of cam is created. That's for the tailboard. So that's what we're going to be doing here. Okay. So what we're going to do is we're going to take our parts. So we are top views, and we're going to just simply select them. Hold down your shift key when you want to select more than one item. Double click to get it in transform mode. I'm just going to hold my control key down and drag them up here. And I'm dragging them up here to the tool path section. Right, this is the final phase, creating the tool path section. All right. So it's kind of a 1, 2, 3, 4 punch. Right. All right. Now, first thing that we got to know is I'm going to come back over here to my end mill. Right. And I'm going to hold down my control key and drag that end mill over, because that's going to represent the end mill that I'm going to be using, my 3/8" bit. Now, the key thing is that bit is going to be drilling in these narrow voids here. Okay, these narrow voids, and it has to fit. If the bit won't fit, um, you know, then you're going to be cutting into your uh, part, and all that stuff. And so, right now, as my layout sits, my end mill not going to fit. So let's measure and let's see how off we are, because I may have to go back to my 1/4" end mill that I use every day. This was the first attempt of wanting to use a 3/8", but not going to have it. So let's see here. Let's grab a horizontal measurement from here to here. All right. 0.362, 0.365 is my end mill bit. 362, it's not going to fit. Okay. So I do have to use a 1/4" end mill, which is fine. What I'm used to using all the time. I just thought I'd be able to use my bigger bit. And if my dovetails were spaced out further, then I would have been able to use it. But so we're going to change this up real quick. We're going to come in here. I want to keep things consistent. So I'm going to go into the size tool and change this back to 0.25. And I'm going to go into my measure tool. I'm going to measure a arc with the dimension. And if I click on this, I can drag that out and click there, 0.25" diameter. All right. So that's going to be the guy that I'm using, my 1/4" bit, which is fine. Thought I'd be able to get away. If I would have spaced my dovetails out further, then I could have used it. But the 1/4" bit's fine. No problem. Does just as well. All right. So on our layout now, what we need is all of this. I wish I could. Here, let me see if I can. Bear with me a second. Let me see if I can do something. Let's go W. No, not there. 0.125. W for waste. And that's what's centered. And this is my T for tail. All right. Okay. Let's take these two and hold down that control key. Drag this over here, let it go. Uh, hold down that control key, drag that over there. That up for a minute. That over there. And snap. Okay. So all the W's are what's getting carved away. Okay. The T's are my tails. So we don't want to lose those. Right. Now you don't need to be putting W and T on your board. I'm just doing this for educational purposes. But the waste areas are the areas that we're carving. Okay. All right. You must have quit. That's funny. All right. So I've got my 1/4 inch end mill. Let's make sure that is the correct bit. 1/4 inch diameter. It is. All right, so the first thing is I'm gonna grab the not this arrow, not this box, but actually put my mouse on the right side of my circle here. And if we went into node editing, there's a node there, so there's actually a snapping point, uh, kind of built into that circle, right? So when I'm in transform mode, I can snap to it, and as you see that box mouse turn to that, showing me where that node is. And that's what I wanna drag that by. I don't wanna drag it by this because 'cause I'm stretching, that little white box. I wanna drag it by the actual line on that node because that's gonna give me the point that I can snap the center of my bit to the edge of my cut on that waste area. So there's gonna be a drilling tool path that's going to carve away that waste material here, right? Okay. Same thing. I'm going to hold down my control key and let's get this kind of front and center on the screen like that. And I'm going to hold down on that edge. I'm going to hold down my control key and I'm going to grab that and I'm going to snap this there. So that's my second drilling operation. All right. It's going to drill down and it's going to remove that edge waste. It's going to help me, to the best of my ability, prevent tear out. If I'm going just back and forth, clearing out like a pocket with the end mill, then I have a tendency of creating tear out because I don't have a backer board. And also, this is going to drill down. It's going to help reduce some of that waste and on the my edges to remove that tear out and stuff. Okay. Now, my 1/4 inch end mill, because of the size of the waste area, that one cut will do the two ends. I don't need to double it up, such as this you see up here, because my inside area is not as wide, right? I'm using only half a pin here, and it's less than a 1/4 inch wide. So that means I'm going to take my control key here, or my little thing here. I'm making copies. Why draw what you can copy? So I'm going to grab the left side on that node of this circle here now, and I'm going to hold down my control key, and now I'm going to snap to the inside corner of this waste area. Okay. Grab this side, hold down my control key, and snap to this side. So there's going to be the bit's going to drill down here. It's going to raise back up and drill down here, and it's going to remove this section. Okay. All right. Now, I can very easily hold down my shift key and select both of these and hold down my controls copy. Shift, the reason why I held the shift for those of you that are new is when you're selecting more than one object, you hold your shift key. Okay. I'm going to double click to put it in transform mode. And I'm going to grab that left corner or left edge, should I say. And I'm holding my control key so I can make a copy. And I'm going to drag that copy and snap it up here. Okay. Y'all awake over there? I should be like Emerald Lagasse and go bam every once in a while. Make sure y'all stay awake. Don't fall asleep. All right. Let's go ahead and again, I'm going to grab it doesn't matter what side I grab, I just make sure what side I snap to over here. And I'm a left handed person, so I'm grabbing from the left. I'm gonna hold down my control key and I'm dragging a copy over and I'm gonna snap it to the inside there, snap it to there, snap it to there, snap it to there in those waist areas. And then finally, I don't need two circles for that. So I'm going to just take this, hold down my shift key and select these two, put them in transform mode. And again, I'm going to just grab it at the bottom here, hold that control key down and snap those two there. So those are the vectors for my drilling toolpath on the tail board. Okay, the circles are the vectors for the drilling toolpath. All right, cool. All right, now with that same 1/4 inch end mill, I'm going to take that 1/4 inch end mill and I'm going to have it do a clearing pass on this outer edge again to prevent tear out and stuff on this outer edge. And then actually this one's not as wide, so one it's going to do it in just one clearing on this outer edge. Okay, so the center of these circles represent the center of my 1/4 inch router bit. Okay, so I'm going to use a line tool now. The line is going to be my vector for my profile toolpath. Okay, I'm doing a profile toolpath and I'm going to snap right to the center of this circle here and snap to the center of that circle there. Now, that line, I don't want my bit to start here and end here. I need it to extend past the part. I want it to start outside the part, travel through and past the back of the part, raise up, come back over, take its pass, raise up, come back over, take its next pass, so on and so forth until that area is cleared out down to that 5/8 of an inch depth of cut. Why 5/8 inch of a depth of cut? Because that's how thick my material is. Plus, we got to also add the 1/16 of an inch because remember, I'm doing an overcut. I want my parts proud. Proud. All right, so what does that mean? That means that I need to extend the length of this line so that my starting point and my end point are past the material. They're starting off the material when they cut. So I'm going to use my size tool here. And from the center of that line, and I'm going to use the center as the anchor so it extends both sides. Okay. And if I were to use one of these anchors, it would extend from that anchor up, this one from this anchor down, but I want it to extend both edges when I resize this length. And I'm going to go 1 inch. All right. And that way, if I could demonstrate this, let me grab a control key here and let me borrow this. My bit's going to come. It's going to start at the start point because if we look at this, if I go into node edit mode, my green node is down here at the bottom. That's my start point. Okay. And so my bit is going to start on this line. It's going to come down at this point. It's going to cut across, end here, raise up, come and make its next pass, its next pass. Okay. All right. My profile vector. Now, completely opposite of this side over here, I started down here for that climb cut, but coming back over here, I'm going to have the router do a conventional cut in this direction to not tear out. So my start point's actually going to be up here for this one. Okay. And on this side. So I'm going to climb on the left, conventional on the right. All right, let's go into here. And again, I'm going to find the center of my circle, snap to that and to the center. space bar to finish. I'll select that line and I'm going to just size it from its center up 1 inch to 1 inch. And that'll extend in both directions that 1 inch. Okay. So that's my two end cuts. All right. Now in here, my bit is going to be making passes, 2 passes. Okay. It's going to drill out this area here, this waste area. And, you know, if the, area was wide enough where there wasn't a whole lot of waste and everything, I could just do a single pass and I may just still do a single pass. If it were narrower grooves, but the, let's see here. Let me hold down my control key and let me experiment here. If my bit comes down, yeah, I'm not going to have it do that. Boop. I'm going to have it do a pocket cut. That's what those rectangles are there for. And I'm an idiot that I almost forgot that. I would have had you running profiles in the middle. All right, pocket cut, ladies and gentlemen. Pocket cut. Pocket. Okay. So in here, we're going to do a pocket cut, and I'm going to grab a rectangle tool and draw a rectangle here. And that rectangle, I want to be 1 inch in length. Okay. So it's going to come in and pocket this out in here with that 1/4 inch end mill. And it's also going to pocket here, here. Now, when I clicked over here on this one, it wasn't centered, right? Don't make that mistake. Go back and look at your vectors and all that good stuff. This one be moved. It's got to be right on the line, ladies and gentlemen. This one here, I overshot in this direction because I was full of myself. And this one here, I got just right. All right, so the rectangle vectors, the drill out here is going to drill out to prevent that chip out on the edges. And then my pocket cut is going to come through and clean out the rest of that waste material down to that 5/8. All right, almost done. We got one more cut, the actual dovetail cut. Now, the dovetail cutter. So all this is going to be cleared out with our end mill. Then our dovetail cutter is going to come and cut those dovetails, that angle cut, that final angle cut. Okay. Cool. All right. So Polyline tool. Now this time, okay. I'm so sorry. This time I want to find the center of my rectangle here because that's going to represent the center of where my dovetail bit is cutting. And the dovetail bit is going to be cutting right through here. Okay. And on this, my dovetail cutter is much wider in diameter, right? So I need, and I'm going to hold the shift key down. Hold the shift key down. I need to extend these lines a little bit longer. I'm going to draw a circle here that my dovetail cutter just in 1730. Let's hit equals. If I click here, okay. So again, the center of my bit, right? I don't want my bit coming down right on the edge of my board. I want it coming out way off my board and everything, and clearing its path. And also, if I were say I want to be, let's say I want to be that far off my board. There's my center, so my line has to be extended out to here on both sides. Okay. So on this, what I'm going to do is I'm going to hold down my shift key and select all three of these. I'm going to put it in transform mode. And this time I'm going to hold my shift key to keep these objects centered. But now I'm going to drag this line and stretch it out. And I can actually move my mouse over and snap to the center of my circle if I wanted to, which it probably won't let me. Are you going to let me snap to you? But I want to get, close to the center of my circle here. And let's see how well I did. Pretty close. I didn't snap to it, but that's close enough. So my bit will come down and start off the board. It'll come down to its full depth of cut and it will come and clear the board. Okay. Now, my dovetail cutter also has to come in and cut these edge cuts here, right? So I need to know where that vector line needs to be on both ends. So if I take and snap the edge of the bit, which this line here, got to understand something here. This line here, right here, this vertical line is representing this upper part, right? It's not representing down here where the actual edge of my dovetail is. So what I need to do is I'm going to draw a polyline, a very long polyline from here all the way up to here. And that's going to represent the edge of where this 17/32 cutter needs to cut. Let me undo that line there. Let's get back into regular mode here. And so, that edge of that cutter needs to cut here. All right. That's where that cutter's cutting. Now, the center of the cutter is way over here. And so if I were to use this line to make a copy of it, hold down my control key and grab it at the end, I could snap to that. And that gives me the vector line that my dovetail cutter has to follow. Okay. Same thing here. Let's get rid of that. We don't need that line any longer. I'm going to draw a line representing the inside of my cut. This is why it's important that all these things be lined up together, in a row, because we work off of them. Draw a line 90 degrees straight up. Space bar to finish. I can take my circle, drag it over here now. Okay. And I want to get the center of my circle kind of in line with that line there. So I'm going to snap it right there. And now I'll use this line and hold down the control key just to make a copy of it and snap it to the center. And that's going to be the vector line. So we have just finished creating the vectors for the tailboard toolpath. Okay. We've just completed the vectors for the tailboard toolpath. All right. So now I'm going to take all of these vectors here and I'm going to right click and I'm going to copy them to a new layer that's going to be called class toolpath vectors. And I'm just going to put TB for tailboard. Okay. All right. And that copy, while it's still selected, I'm going to drag it over here because we're going to be using it in a few moments to set up our toolpath. Okay. All right. Now, We're almost at the home stretch, guys. How y'all doing? Y'all hanging on with me? Huh? Y'all need to take a break from that and look at this pretty face and see you smile. See you smile. Not the best smile, but it'll work. All right. Hopefully y'all are still with me. We're almost ready to create the tailboards, but let's see here. Hey, Mr. Mac, welcome. Hi, haha. Good to see you, buddy. Long time no see. Thanks for the comment on last week's video and stuff. I appreciate you. All right. So now we've got to just create our drilling tool paths for our pin board and our pocket cut. There's no dovetail cutter that's going to be used on the pin board. So let's go ahead and jump into that. Everybody still with me? All right. We had 65. We're down to 56. 10 of them said, "Oh, I got to go for right now. My head's spinning." All right. Let's get back to it and let's see how we do here. All right. Sprite. Yeah, Cecil. I stopped drinking Dr. Pepper. It put me in the hospital, so I had to start drinking. I was supposed to drinking juice, but Sprite was. I couldn't give up soda altogether. All right. Yeah. When you're hunched over crying like a baby because you're passing a kidney stone, it's time to give up some Dr. Pepper. Oh, that's the worst pain I ever experienced in my life. God bless women who can endure pain. Okay. All right. So now we've got to create our tool paths for our pin board. All right. And very similar to the tailboard, we're going to have drilling operations, and then we're going to have a pocket cut. Okay. We have drilling operations, and then we're going to have a pocket cut. So I'm going to snag one of these 1/4-inch circles over here. I'm going to hold down the control key so I can drag a copy over here so we can use it. Why draw what you can copy? And here, these, if we need some W's and T's, let's drag a couple of W's and T's over too. Hold down the control key. All right. Now, this, let's get rid of the W or the T because it's not a tail, it'd be a pin, but we'll use the W, okay? On the W. All right. This is our waist area. Hold down that control key. This is our waist area. This is our waist area. And this is our waist area. That's the area that we're machining to remove. All right. All right. All right. Now, once again, just like we did before, I'm going to grab the corner of this and I'm going to come over here and snap to the edge here. And I'm going to hold down my control key, grab this edge and snap over to here. Okay. And then down here, I'm going to hold down my control key and snap to this edge. Hold down my control key. Snap to this edge. And I'm not going to I'm going to try to snap right into the middle of these two. Let me see if I can do that. Can I snap to the middle? I don't think it'll show me the middle. That's all right. We're going to find that happy middle where I got just enough overlap. All righty. All righty. Okay. Now, all right, and so that's going to come through and clear out that waist area. All right. All righty. Now, notice on this old one up here, I didn't need that because my dovetail cutter was a very small dovetail cutter, so it just only needed 2 vectors. This one, a little wider here, so 3 of those 1/4-inch end mills. This would probably be a good one where my 3/8-inch end mill, right? I could use, since it's a completely different tool path and I got to change tools anyway. I could switch to my 3/8 inch end mill here instead of my 1/4 inch. That'll give me an extra 1/8 of an inch, but I still don't think I would overlap on that down there. Let me check. Let me see here. Let me find out. Just for kicks and giggles. 0.375. Oh yeah, I think I would overlap. Oh yeah. Will my 3/8 inch end mill fit up in here? Oh yeah. Oh. Okay. All right. Um, let me see here. For consistency's sake, for you guys and all, we're just gonna stick with the 1/4 inch end mill. Okay. Yeah, we'll just stick with the 1/4 inch end mill. If you were doing something like this, use the, use the optimal tool path or tool for, to meet your needs and all that stuff. But for right now, I'm just gonna stick with the 1/4 inch. All right. So I'm gonna grab all of these and hold down my control key, and I'm going to snap. Are you not gonna snap for me now? Oh, it wasn't snapping because it was holding the shift key, not the control key. There we go. That's how you snap. All right, let's go ahead and drag this over and drag this over. Okie dokie, tokie dokie. All right, good to go. Good to go. All right, now, no, just for kicks and giggles, I want to see how good I am here for a minute. Not good I am. I want to do a measurement here. I want to measure from here to here. And I want to measure from here to here. 47124. 47124. That's good. Okay. Who is calling me on a Tuesday night? Okay. Sorry about that. I'll call him back. Whoever's ringing me, I'll call you back. Okay, now here we go. Now we are going to create the pocket cuts because this is the drilling operation. Again, the drilling operation is going to drill down in a series of steps to help kind of reduce the chip out on the edges. And then we're going to have a pocket come and clean up all of this and flatten it out. Now, on the pocket cut, I'm going to utilize the tangent tool uh, to connect these vectors with a tangent and everything. And so what I would like to do right now to do that is I'm going to create a new layer, okay? And on this new layer, I'm going to call this layer my pin board pocket vectors, okay? And I'm going to take these vectors here. Sorry about that little screen jump. And I'm going to copy them to that pinboard vector layer for a minute. And then that way, just to, I'm going to shut off all these other layers to hide all of that other stuff except for, uh, you know, these vectors. So I got everything shut off, closing down everything. And all I have left is just those circles right there because we're going to use them. All right. So what I'm going to do is I'm going to take my line tool here, my Polyline tool. Make sure you're in the proper layer that you're working in. And I'm going to click on one of these circles and then I'm going to hover. I'm not going to click on this other circle. I'm going to hover over this other circle and hit the letter T on my keyboard. And that is going to snap. It's snap now. Bear with me a second. Are you not going to snap? Bear with me a minute here. Don't you argue with me. All right. So then on the top, it's not going to snap, but on the sides, it will. So we'll do that on the sides. For this one, we're going to just find the center point of this circle, and we're going to find the center point of that circle and snap that line straight across. All right. Now on the side, when I click here and I hover down here, when I hit that T, it's, are you kidding? Why isn't my tangents turned on? Oh, well, come on. Is it because I'm not in my updated version of the software? Hold on a second. That's a, da-da-da. Is it because of that? Snap options. Smart snapping object bounds. Snap to grid. Let me see if where's tangent. Span midpoints. Arc centers. Intersections. Tangents. Tangents is turned on. You son of a gun. Let's try that one more time. It shouldn't be doing it because of these overlaps here. Should click, hover, letter T. Is it? All right, hold on a second, guys. We got to fix. We got to find a problem here. I'm gonna get rid of this overlapping one here just for a minute, just to see if that's what it is. Click, hover, T for tangent. That's my T key is broke on my keyboard. What in the world? Wonder if that's what my update. Oh damn. That T should snap right to my tangent. All right, that's fine. Well, we're gonna find. I'm gonna just automatically snap to the tangent of the circle. Maybe the T key was in version 9.5. Maybe they did it automatically where it automatically just snaps with the smart snapping now. Let's find that. Let's find out. Hold on a second. Let's see if that's true. Maybe the T is no longer required. So if I come up here and I come to this circle and I click, is that my tangent? It's not my tangent here. Interesting. Interesting. All right, no problem. We'll continue on with what we got to continue on with. But it would be nice if you know, it did snap to our tangents, but right now I'm just using the center points of the vectors. I will figure out what that is and why it's not working. I don't know if it's. Let me pop over here real quick. Let me see if VCarve Pro circle. circle, click, hover, T. See, that snapped me to my tangent. What's up, Aspire? That worked exactly like it's supposed to. What's up, hover. Even if I'm way up here and I hit T for tangent, snaps me right to that tangent. Both lines. Space bar. And, come in here and trim, and there's my cam. So why isn't that working on Aspire? I'll have to figure that one out. It might be because of the update. That might be a patch or fix in something in this version that I'm running in. But that's all right. We'll still make it happen here. T is the tool for tangent, the keyboard shortcut. And yeah, I'll have to figure out why my Aspire isn't. But I'm just snapping to these center points, which will get me where I need to get. All right, so with that, I'm going to come in here and I'm going to trim away. Oops. I'm going to trim away these vectors. Okay, to create that pocket. All right, and then I've got this little guy. So we'll get rid of him and him. These outside little circles here, which is fine. My dovetail bit will come in and clean up wherever it couldn't get. All right, 2 more to do. Just trimming away these inside circular areas here. This outside here. This outside here. Sorry about the in and out. Just trying to move along. Okay, one more. Oops. Control Z to undo. That disappoints me. My tangent tool didn't work, but there might be a reason. I have to go back and just research it. It takes me a second to think about something and figure out why it's not working, but now is not the time to do that. If I figure out what it was, I will definitely let y'all know. All right, so now I have the vectors for my pocket cuts. So I can go ahead and turn my other tool pass back on, or my other vectors and things here and stuff. And so I have the pocket vectors, and then I have my end drilling vectors. So that one is done. That's my tailboard vector. So again, I'm going to make a copy of these. Hold down my control key and drag a copy over here. All right. Now, let's get rid of these vectors here, and let's go look at our job setup. So our job setup, our actual job setup now. My job setup, my board is going to be 0.625 inches wide. The board is 0.625 inches wide. The height basically represents the width of the board, which is 4 inches. I'm so sorry, which is 4 inches. And the thickness, I'm going to put 2 inches in here just so I can see an end view. When I've got this turned to its side, I want to be able to see that 2-inch end view and stuff. So now I'm going to be working. If I were to draw out my CNC machine for a moment, just so you can kind of get an idea here. Imagine that this is my CNC machine here, and I've got my gantry, and we'll just pretend that's a round router. my joint making jig clamps onto the table and has, the vertical and everything that goes down. And the part here is going to be clamping to the jig on that table. Okay. And so on the outside corner here, this bottom left corner, that's where I want to start from. I want my bit to start out here and then go around and do it some drilling and everything. So this is representing a top view in the job setup. Okay. The top view. So let's get rid of that. So back in my job setup, my board again, like I said, is 0.625 inches thick. It is 4 inches wide, and I'm just going to put a thickness of 2 inches so I can see, like you guys can see, kind of like an end cut when I do the preview of the tool paths. I'm going to be touching off on the top of the material at the bottom left corner, which is going to represent that outside left corner of the piece. We're going to click OK. And now if I were to look in the 3D view, oh, hold on a second. If I were to look at a 3D view, basically we're going to be cutting on the edge here. And that 2 inches just kind of gives us some length of the board because that board is going to be hanging vertically. So you'll be able to see the cuts and everything. Now, the only thing that Vectric cannot show is the undercuts. Okay. Um, the only thing the Vectric cannot show is the undercuts of the dovetail toolpath, but you'll be able to get the idea. Now let's stop back for a moment. Well, how you doing, Michael? Good to see you, buddy. I gotta watch my language. Sorry, Michael's our youngest viewer. Let's see here. Oh, snap, it won't snap. There you go, Dean. Let me see here. Dean asked a question. Can you hold down the shift key and drag the scissors over multiple lines you want to erase, like in SketchUp, Laney? Uh, Michael? I didn't even know you could do that in SketchUp. I've never really tried to be able to answer that question. Can you hold down your shift key to cut multiple lines like you can in SketchUp? So if I have my scissor tool here, to trim overlapping vectors, click on the selection of the vector you want to delete. To delete crossed, non-overlapping vectors, hold down the shift key when clicking. So I think the shift key only has a purpose um, of, if I hold the shift key down and left click, I'm just holding my left mouse button down and my shift key right now and just moving over the line. That doesn't do anything. My scissors open and close, showing me where lines I can cut are, but I have to actually let go of my mouse button, you know. Um, and what that does, it allows me to, holding the shift key allows me to cut sections of lines, you know. So no, buddy bro. Thanks. All right. Let's create some tool paths here. So the first tool pass we'll create is, do we cut the tail board or the pin board first? Which one? Um, I'm gonna create the cut that I'm gonna do first is gonna be the tail board. And the reason for that is if I needed to make any adjustment or offset allowance on my pin board, I can do that. I can create that offset allowance in that pocket cut to make it just a little bit wider. If my pieces are, hard pressed to fit together. So with that being said, let's go ahead and take our tailboard vectors. I'll just drag it here. And I'm going to hit the 0 key on my keyboard to rotate that. Okay. counterclockwise. And the key thing is I want, on this side, I want this to be my start point. And, or actually on this side over here, I want this to be my start point. So if that node is green and I've got it orientated in the right direction, excellent, it is. Oops, let's get out of node editing. All right, let's go ahead and get this centered up on our material. So I'm going to go into the alignment tool and center to material. And I think you guys know what's the waste and all that is now, so we'll get rid of this. And I still haven't centered it to the material yet, ladies and gents. All right, let's select that and are any of my tools working today? Let's see here. It's snapping to something. I got to figure out what the hell it's snapping to. It certainly wasn't snapping to what I wanted it to snap to. All right. That's weird. Something's. Do I have? Weird, weird, weird things are happening with my software. Okay. All right. So let's go ahead and create some tool paths. Now, I'm going to delete these tool paths so it doesn't, not to confuse you. And we're going to start from scratch. All right. The first tool path is going to be our drilling operation with our 1/4-inch end mill on our tailboard. So we're going to select all of our circles here. And here, let's do this. We'll do vector selection order. So I'm going to select these in the order that I want to drill them. So I'm selecting the vectors in the order that I want to drill them. Okay. And that's going to be a drilling tool path. And the depth of cut is going to be my 0.625 plus let's try that again, not the enter key, plus that 1/16 of an inch, because I want that, I want it to be just slightly proud when I put the pieces together, and I'll sand them flush, get it nice and tight, right? All right. So that's going to be my cut depth. I'm going to use my 1/4-inch end mill, and I'm definitely going to use pecking. I'm going to let it just go down and peck in that. I do not need it to dwell at the bottom of the cut, but I do want to use the vector selection order. Okay. And so this is going to be my tailboard drilling. And it's going to be the point. I'm just going to go Dovetail Box DTB. And it's going to be a 0.25. All right, let's calculate that. And let's take a preview of that. Okay. So basically, it's going to go down and drill those edges and everything here. All right, and that's just going to help prevent tear out when that pocket, that profile cut, comes and cuts and everything. All right, now the next cut is also going to be it's going to be my short line. The short line, it's going to be the short line for the profile cut here on the two ends. Okay. And again, vector selection order. Now this time I want to use not only the vector selection order, but I also want to keep my current start points because I want it to come here and do a profile cut, come around, and then come here and do a profile cut. Okay. So I'm going to do a profile toolpath, cutting down 0.625 plus 0.0625 equals, which is 0.6875. And I'll just type that in next time now that you guys know what the math is and all. Using a yeah, I'm going to use an upcut spiral bit. That's fine. And I want to be on the line. I want the center of the bit cutting on the line. So I'll use my upcut bit for that. Cutting on the line. Now coming down here to the order. If you don't see these advanced options down here, check the box up here that says show advanced toolpath options, okay? On the order, I want to use the vector selection order, and the start at, I want to keep current start points. I don't want to optimize them. I want to keep the current start points. Now, notice it shows this start point here on this side, and that's not where it's supposed to be. So I'm going to go into node editing on that line, and I'm going to right click on this black node right here and make that the start point. All right, get out of node editing, and I'm going to select my two vectors again. Okay, I want that bit to come and cut, and then over here to cut in this direction. So it'll do a climb and a conventional. All right, let's go ahead and this is going to be my tailboard end cuts. 0.25 dovetail box. 0.25 mil. All right, we'll calculate that. All right, and so let's get this kind of tilted and all. Basically, what it's going to do is it's going to come in and cut that raise up. It's going to be cutting in that one direction on this side here for those passes, bringing that end piece down. And then on the other side, and sorry, it's so slow. I'll turn the speed down, or here, actually, let's do that right now. I'll turn the preview simulation quality down, so it's a little faster. And let's preview all the tool paths. Okay, so that's going to be my two end cuts with the end mill. All right. Now I've got my pocket cuts. Okay, got my pocket cuts. So on my pocket cuts, they are going to be cutting that 0.06875. And 1/4 inch end mill. They're going to offset cut. And this is going to be my board pockets. Dovetail box. 0.25 mil. Calculate that. And so that will go through and pocket out those areas. And it would help if I had the right depth of cut. 0.6875, not 0.6875. How many of you caught that? Let's calculate that again. There we go. That'll go through and pocket those areas out. We do the drilling operation to help reduce chip out on the edges, on the two edges and everything, and all that. Now, the one thing that I said is that we couldn't show the undercut of the dovetail cutter. When I run this toolpath, the only thing that you're going to see are this last toolpath that I'm about to create. All you're going to see are these openings get wider. Uh, it won't show that angled cut of the dovetail cut. So, um, you won't be able to see those undercuts. Vectric can't show the undercuts. All right. So our last tool path is going to be the dovetail cutter. Now on this one, I want my dovetail cutter coming out and cutting through, raising up, cutting through in one direction because it's doing it in one pass. Now, the one thing that I don't have is I do not have the dovetail cutter added to my tool database. This particular one that I'm going to be using, so I have to add it. But I'm going to select all of these longer vectors here. These are my longer lines. That's my dovetail bit lines. And it's going to be a profile cut, cutting the 0.6875 with my dovetail bit, but you can't add a dovetail bit to your tool database because you can't draw the undercuts. You have to use what is called a dummy bit. And let me close all of these up here. And in my dummy bits, I have a dovetail cutter, but it's only a 3/8 inch diameter one. So I'm going to add in that category a new end mill. And it's going to have a diameter of the 17/32. That's the diameter of the dovetail. It's 2 flutes. We're going to copy from, not from that. We're going to copy from none of those. None of that. All right, we're going to set our own parameters. All right, the pass depth is going to be the full depth of cut on this, okay? Now for this cutter, the carbide flute, is the carbide length, should I say, not the flute. The carbide flute is 25/32. Okay. So as a default, that's what I'm going to put in here, but that's not my depth of cut. I'm just setting the parameter for this bit. The step over, basically there is no step over, but if I were using making wide dovetails with this bit, then I would want it to step over 33.3% of the bit, a third of the bit. The spindle speed on this cutter, the recommended spindle speed on this cutter is, let's see here, 18,000 RPMs. I just looked that up on their Fruit's website. The feed rate for this is going to be doing one pass coming through. I'm going to run it at 50 inches a minute, and I'm going to have it plunge at 20. So I'll go ahead and click apply on that to add that in, and I'm going to rename it. Let's rename it first. This is going to be my 1732. All right. And with that, I'm going to select that and add that to here. Now it's set up for one pass because the pass depth, is going to be 6875, which is not, exceeding its pass depth. That's good. And that's what I want, one pass. And I want it to be on the line, cutting right down. I want the center of the bit right on that line. On this, all of my start points are on this edge here, cutting in this direction. Now my bit is spinning here. So when it's cutting, it's going to be cutting into the part. And I don't want that. I want it to be raking away at those parts and all. So I want to change those start points. I want to reverse them. And let's go into, I could, for time's sake, go climb, conventional, climb, conventional, climb, zoom, 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 zoom. But I'm going to have it run in one direction. So I want to go into node editing mode real quick. And I want to make that the start point. Make that the start point. Make that. And make that the start point. Get out of node editing. Select my vectors again. And with that, on my start, I want to keep the current start points. I'll use the vector selection order. That's fine. And I'm going to go ahead and give this a name. This is the last tailboard toolpath of tail cut. And it's my Dovetail Bit. 1932 Dovetail Bit. Calculate that. Now, unfortunately, we're not going to see the undercut, but when I preview this, it's just going to make the cuts wider in those areas, representing, that final piece. Unfortunately, it looks like a finger joint, but it will be a dovetail joint. All right, how many of you still with me? Y'all good? 52 of you. All right, we're almost done here, guys and girls. This could be a two-parter because it's 9:37. Let's get the dovetails done, and we might have to come back before we go into the shop. We might have to create the other parts and everything. The cuts for the other parts, the toolpath, because there's some work to do on that as well. All right, so with that, with those vectors there, I believe I have my, they're on my class toolpath vectors right here, all together, even my, wait, hold on. What's the name of that? That's my tailboard, toolpath vectors. Okay, good. I can turn that off. And these guys here, I'm going to move them to a new layer. This layer is going to be my class toolpath vector PB for pin board. And click OK on that. Make sure that that layer is active that I'm working in. And again, I'm going to rotate this clockwise by hitting the 0 key twice. I'm going to use my alignment tool and I'm going to align to the center of my material. And let's see how well that went. That one did good. I don't know what was up with the other one. All right, let's get rid of these W's. We're not V carving in here tonight. This one we have two toolpaths, two very simple toolpaths. So we are going to be select that one, hold down the shift key, select those. Let's do the vector selection order. That way it cuts around the board. I was going to try to be slick and have it do each pin, but that's all right. We'll do order. Oops. Okay. This is going to be a drilling tool path, cutting my 0.6875 inches deep with a 1/4 inch end mill using pecking. I'm going to use the vector selection order, and this is going to be my pin board drilling box, 0.25 end mill. All right, let's calculate that tool path, reset this preview that selected tool path, and that will be that drilling operation, getting those edges cleaned up for us and all. Help reduce chip out on our pocket cuts. And then our next vectors are going to be our pocket cut vectors here. Okay. And that's going to be a pocket cut, cutting 0.6875 with a 1/4 inch end mill. I'm going to have it do it in 6 passes. I'm going to offset, and this is going to be my board pocket Dovetail box, 0.25 end mill. We can calculate that, and we can preview that selected tool path. All right, and that's going to be our pin board. Okay. Now those tool paths will do both sides of your pin board and both sides of your tail board. Just make sure that however you're clamped on your table. Um, make sure that you flip that board from end to end, not flip it over from. You don't want to flip it in this direction because then it'll be backwards, right? You want to make sure that you flip it from end to end in this direction when you flip your board, okay? So that they're in the same orientation. Because that would suck. It would. And your front, this will do your both ends of your pin board, front and back. And the other tool path will do both ends of your tail board, front and back. Okay. So that is all we needed for our tool paths to cut our dovetails for our dovetail box. All right, let's kind of stop here for a second. Let's get over and let's see if there's any questions. Any questions up to this point? Yeah, instead of so instead of the great class in spite of the tangent key issue, I don't know what's happening with the tangent uh toolpath in my Vectric. Let me see something here. I'm going to draw a small circle here and a big circle here. And I want to see if it's just because my circles were the same size, which should not be the case. But if it is, I'm going to freak out. I won't be able to figure it out. All right, I'm going to just hover over this. If I hit the letter T on my keyboard, it snapped right to the tangent. Why? So that worked. T for tangent, snaps it right to the tangent. Huh. Interesting. But if my circles are the same size, T for tangent, it snapped it that time. What's happening now? Why is it working now, but it wasn't working before? If let's say I go on the inside of this line here, right? I'm just hovering. If I hit T, snaps it right to the tangent, space bar. Okay, now I don't know what the deal was with that. What's the deal with that? why it wouldn't work. Let's go here on the inside here and hover T for tangent. No, I think it's because the lines are actually the circles are overlapping. If I test that theory, escape. If I test that theory, now they're not overlapping. And I don't want to do my text tool. I want to do my line tool, man. Text tool. Hover T for tangent. Okay. So no, that's not the theory. Wonder what the deal is. I don't know. I don't know. I do not know. But it's working. I just don't know why it's not working here. That's okay. It might be got to be on your board kind of thing, even though I just did it up here, so that wouldn't be true. But let's see here. Click here. If I hover here, I'm gonna actually hover down here. T for tangent. T for tangent. T for tangent. Nope, nothing. All right. I don't know what it is. I'll have to figure it out. I have to talk with Vectric and find out what the deal is. But it does work, but it's just not working on these particular vectors. Don't ask me why. So, all right, let's go and see what we got. Any other questions? Haha. I'm glad your son's into it, Crystal. That's great. Get him out on the CNC machine. Make some little toys, little tic-tac-toe games and stuff like that. Something he can play with, and really get him into it. That way, he's really excited about it when he grows up. Let's see here. Let's get let's minimize this for a second. Oh, hey guys, how y'all doing? If you're doing a dog bone, it is drawn in the similar way. Is it drawn in the similar way on the dog if you're doing a dog bone? Um, oh, like an actual dog, like not a dog bone fillet, but an actual dog bone? Yeah, a dog bone would be drawn the similar way. Basically, let's see here. Let's what I don't know why I'm doing that. Close that. Take this, hold down the control key, drag a copy and snap it to here. Select both of these, hold down your control key, drag a copy and snap it to here. Make sure you hold your control key and not the shift key. Take your rectangle tool and basically whatever size your dog bone's going to be. Ah, boy, my buttons just aren't clicking very well today. And however whatever you want your dog bone to be, and then basically it's a trim tool or a weld tool, either one. But in this case, we actually want to use the trim tool. Oops, I clicked first line. I clicked with the wrong line. We want to use the trim tool. Oops, don't trim away that line. Come on now. Okay, nice. Okay. If you're drawing a dog bone. Now, hopefully that's what you meant with the question. Dog bone. But, and then, of course, you would want to saw these corners, the fillet, and you could, let's throw a big 1-inch fillet in there so y'all can actually see it. Soften up those inside corners. And there's your dog bone. All right, all right. Okay. So let's see here. Dr. Pepper withdrawals. That's right, pal. Dr. Pepper withdrawals. Um, let's see here. Let me go up into these questions and all. Agree. They're very interesting. Carl, absolutely. If you want to check out hand cut dovetails, I have a video on that as well too. on my main YouTube channel. Carl says, interesting, but he'll stick to hand cut dovetails. And that's absolutely fine. On my, custom things and stuff, hand cut dovetails are very nice and elegant and all. But when I'm running a production run, I'm going to set them up for the CNC. But yeah, I love doing hand cut dovetails too, but those are for my heirloom pieces when I'm doing production runs and I'm making, 3 or 4 of these same boxes and stuff. Uh, they're going to get cut on the CNC. I'm not gonna hand cut 4 boxes of dovetails. Uh, let's see. Yeah, Rodney, the T was working in mine too somewhat. Sometimes it was, sometimes it wasn't. Let's see here. Let me see here. Yeah, I'll make sure I keep my language in check. I have a trial version of Aspire and the tangent tool works fine. Yeah, I'm not sure what was going on with the tangent tool. All right, let's get past that. I'm trying to look at questions and see if I'm missing anything. From the other night, where do you get the Dynaglide lube you use? The Dynaglide lube. Lowe's. Lowe's. I'm a Lowe's shopper for little things. Not all the things. Amazon and Lowe's, but for the Dynaglide, it's Lowe's. I'm trying to. You guys are having a cool conversation on y'all's own. Um, My keyboard has had enough abuse. As a matter of fact, I spilt my Sprite on it yesterday, so I got to go out and buy a new keyboard because all the keys are sticking, and that could be. That's not the reason why the tangent key's not working. Why it wasn't working on there, but yeah, my keys today I noticed they were just getting a little hard to press, and it's because I got so excited during the Courage project. I stood up after doing the design and everything. I stood up to go into the kitchen, and I went to grab my can of soda, and instead of grabbing it, I tipped it, and it just flooded my keyboard. So I got to go pick up a new one. It gives me an excuse to buy a new keyboard anyway. I want one. I want one that lights up. I don't know why, but I do. All right, let's see here. Gotta hold your mouth right. Yeah, let's see here. It, I don't know what it could be. All right, I like rewatching this in real time. What is the time to cut the pins and tails? I have a Porter cable dovetail jig. What's the time to cut the pins and tails? I have a Porter cable dovetail jig and can knock them out pretty fast once it's set up. The times on this, based on my speeds and feeds, 14 minutes and 30 seconds. So let's break it down. The tailboard is 34 seconds, 1 minute 24 seconds, 1 minute 39, 3 minutes, and then the pin board is 2 minutes and 41 seconds and 4, so 6 minutes for that. And that was one end. That was one side. Then all I have to do once I have it set up, all I have to do is flip the board, secure the clamp, and zero out and hit start. Because my X and Y zero remain the same, I just touch off my Z. So good question, Jim. Let's see here. Yeah, I know. Good thing it wasn't Dr. Pepper. It would have melted if I would have spilt that on my keyboard. How far over does the spindle go on your table, Rodney? Good question. On my table, the center of the bit over travels the front of the table by 3 inches, 3.5 inches. So great question. So I can carve the center of the bit over travels by 3.5 inches. So my J is guess 3/4 and a half, 1.25 inches wide. So that gives me 2 3/4 inch thickness material that I can work with on it. I got to take into account my router bit too. So roughly about 2 inch thick material I can work with, depending on the bit. All right. So, ladies and gentlemen, it is 9:55. What we're gonna do, we got to kind of break this up. I want to, we're gonna say our goodbyes here this last 5 minutes. Uh, I want to talk to you about this here that we brought these tool paths in to create these tool paths and all. So what we may do is, if you want to join me again, just like we did last week, this is going to be a multi-part series. We're going to be out in the shop setting up the joint making jig and cutting these dovetail joints live and everything. Um, the inside cuts on the parts and stuff, we probably won't see that. I may video that. We could do it live. I'm not sure, but I'm trying to figure out how this one's kind of a there's some time involved in this one because the lid's going to be a 3D model cut, and I haven't designed it yet. But I'm assuming it's going to be, quite a few hours, so we might not get to see the lid cut unless I just filmed it or something and showed you bits and pieces of it, which I could do. Not a problem. I could do it like a replay, a fast forward replay or something. We are going to definitely see the dovetail and the pin boards get cut. We're going to cut those so we can check our fit, right? So you guys can see what the joint looks like when it comes together. We're going to do that Thursday night at 7 o'clock. If you want to join me Thursday night at 7 o'clock, we're going to cut the dovetails and everything. But what we may do is Thursday. What I'm going to do is tonight, I'm going to release a non-live video. It's going to be a recorded video on creating the toolpath vectors for this, doing the layout and toolpath vectors. And I will post that up in Spindle TV. So it'll be a video that you can watch. It will not be live. And then Thursday night at 7, we will do our actual cuts, and everything. And I don't know if we'll be able to get to all the cuts, but we definitely will get to the dovetail cuts. Okay. So hopefully you can see the now hold on a second. Let's go back up here and stand by 1 second. I want to find where was it? Where were you at, John? Bear with me. I want to see if you were if I just answered a dumb question. Give me a second. Give me a second. This maybe let me would this. John, I'm not seeing your post. Wait, hold on. Oh, if you're doing a dog bone in the drawing, is it similar way? Okay. So you were referring, John comes back and says, sorry, Lainey, I was referring to a hold on. John says, sorry, Lainey, I was talking about the isolock joint. Looks like a half of a dog bone cut. No, John, this would not be that way. Let me take a quick second and show you what that would look like. Okay. Similar as far as the drawing, but let me take a quick second and show you what that would look like. Um, he was talking about the dog bone joint, decorative joint. And so what he was referring to is like also referred to as kind of the heart joint or things when you're doing decorative joints. So here is a decorative spade joint. The one he was referring to, let me turn off the spade joint. is kind of a dog bone joint, looks like a dog bone, like this here. And with the dog bone joint, John, same layout as far as the job setup. The In this case, I got my boards 3/4 inches thick by 3.5 inches in length in this particular job setup. 3 inches thickness to show the end cuts. You have a profile cut, or this will be laying vertical on your table, hanging off the edge of the table, and the bit will come and cut this profile, and this waist piece will just fall off, and you'll have your profile cut. And on the horizontal cut, you will have a pocket that will come and get cleared out. So it would look like this if we were to preview it in the toolpath. So the pocket cut would come in, and I should have tilted the board, but we'll let it preview there. Sorry about that, John. I didn't know you were talking about the engraves. We will talk about decorative joints. I have quite a few decorative joints, heart joints, spade joints, finger joints, and different things like that. These little decorative joints. They're basically like half blind dovetails, if you will, but they have decorative shapes to them, such as these cute little dog bone or heart joints, whatever you want to call them. And basically, this would be your pocket cut. This would be your pin board. Okay, this would be the pin board. And then the tail board, which I can't really demonstrate the end getting cut off, but um, let's, yes, I can demonstrate the tail being cut off. Hold on a second. So this board would be laying horizontal on your table, and it would be a profile cut, and this waist piece here would be fall off, and that would be your tail board. Okay, that would be the tail board. So that decorative bone joint. Now, in these particular tool paths and everything here, I have a half profile. Depending on what size my board is, that half profile, and I have different profiles. So that's the dog bone. We've got this kind of interlocking, rough-looking kind of spade, if you will. We have a kind of a different variation of that. Another variation, kind of these locking circles, and then an actual spade joint. And so on this profile, basically it's kind of a half profile from the center, half, and I could simply, depending on how long the piece is or how wide it is, should I say, I can go into the mirror tool and just keep flipping, making a mirror copy, and just keep flipping to the bottom to lay out those, you know, tails or pins, you know, whatever it may be. And as far as the pocket cut, let me undo that here. As far as the pocket cut version of that, basically, it's taking the end piece and closing it in. Okay, so it cuts that pocket, and then of course there's a little bit of an allowance so the two parts can fit together. But yeah, decorative joints are easy to lay out and all. You just need to make sure that they interlock in some way. But as far as cutting them and the way they lay out and everything, your pocket cut here is on the vertical board, and the profile cut is on the horizontal board. So hopefully that got back to you and answered that question. All right, let's get back to our dovetails here and things and turn off these tool paths. All right, let's see what else I missed. Thursday at 7:15. Thank you, Crystal, for correcting me. Thursday at 7:15. Now, ladies and gentlemen, tomorrow night on the Digital Woodcarver YouTube page or Digital Woodcarver Facebook page, Burl and I are going to be talking about the joint making jig, and we're going to be demonstrating it and everything. You're actually going to see it set up. If you want to see that, 7 o'clock tomorrow, tomorrow night, 7 o'clock, not 7:15, 7 o'clock. But Thursday at 7:15, I'll be cutting these dovetails that we made tonight, and then sometime between now and Thursday, there's going to be a video posted on Spindle TV, and I'll put the link in Spindle Training Videos on Facebook for you guys to get linked to. That will be the toolpath and everything for toolpathing for the rest of the pieces and stuff. All right, everybody. We are at 10:05. We're kind of almost at our 2-hour mark here, or 3-hour mark, and I think we've gone on too long. I've racked your brains on this. Just hope that you maybe pick something out of it, whether it be phase one, laying out your dovetail bit, your cutter, 2, doing the layout, 3, creating the pin board, which is down here, and then 4, creating your tool paths and things, or your vectors for your tool paths. Hopefully that little lesson, and hopefully being able to go back and rewatch this video and stuff, you might be able to get into it. And then once you do it once or twice, it becomes clockwork. And for me, I keep this layout on my screen, even though this is the only part I'm using for tool pathing over here. I always keep this layout on my screen so I can follow my little procedure. You know, I delete what I need to delete and just recreate it so I can have my little workflow. And it's just good for me. It's how I kind of operate and stuff. Um, but yeah, will make me a smaller net bigger, but hopefully that helped. I'm in Eastern time, so 7:15 Eastern daylight time right now. So Thursday night, check me out live. We'll be out in the shop. We're gonna cut these dovetails on the joint making jig and see what other cuts we can get into and stuff and other discussions. All right. I want to thank each and every one of you. I know I say that 100 times before I say my goodbyes, but I really do want to thank each and every one of you. You for sticking with me. Now we lost in that short time because of just the rambling and the talking and all. We went from 60 down to 30, so everybody's starting to fade out and go bye-bye now. So we're going to do the same thing. We're going to say our goodbyes. And so once again, thank you. And until next time, I'll see you soon. I appreciate y'all.